Okay, so let's look at this practice problem number 3, where a football player is initially at rest, which means that they're not moving, so their velocity is 0. And they're going to accelerate uniformly as they run down the field, traveling 17 meters east in 3.8 seconds. And we want to figure out what their final velocity is. So again, I'm going to write down all of the variables that I have on my sheet of paper in front of me. I know my V1 is 0. I know that I'm looking for my V2. I have a displacement and I have a time. So if I'm looking at my equations, I know that I have a V1, I know that I'm looking for a VF, and I have a time, and I need, I'm looking for a displacement. So this first equation actually fits everything that we need. So this is what we're gonna use, okay? So I'm just gonna quickly copy everything down. I know that my displacement equals V1 plus V2 all times t divided by 2. And again, you can put these arrows in here. Remember, we talked about it today that sometimes we just take them out to make the equation look a little bit neater. It's kind of hard for me to do them on the mouse, but we'll try to keep consistent. So I'm going to fill in the information that I know. I know that my distance was 17 meters. I know that my V1 was 0. I'm looking for my V2. And I know that my time was 3.8 seconds. And all of this mess was divided by 2. That's just part of the equation there. So I'm going to do everything that I can do to simplify this problem. The first thing that I'm actually going to do is I'm going to get rid of this 0. So I'm going to just say that this is the same thing. 17 is the same thing as saying V2 times 3.8 divided by 2. And I get rid of the 0 because 0 plus V2 is just V2. Okay? And I want to get V2, or my final velocity, by itself. And the first thing I'm going to get rid of is this divide by 2. And we're going to do the exact same thing that we did in the last equation. If I'm dividing by 2 on one side, I need to do the opposite operation to bring it across the equal sign. So I'm actually going to multiply it by 2 to bring it across the equal sign. So I'm going to end up doing 17 times 2. And that equals V2 times 3.8. 17 times 2 is 34. And now I'm going to assess what's left in my equation. I almost have V2 by itself. I see that it's beside this 3.8, and we're multiplying these two things together. So to undo this multiplication, I just need to divide my left-hand side by 3.8. That leaves me with V2 by itself. It's nice and isolated. And in my calculator, I'm going to do 34 divided by 3.8, and I get 8.9 and a bunch of decimals, which just rounds down to 8.9. And this is, of course, meters per second. And I just need to do a quick double check to make sure what my displacement direction is going to be. So I pop back to the question. I notice that she's running east, which means that my velocity also needs to be east. Okay, and remember, in order for this to be a vector and not speed, so in order for this to be velocity and not speed, I need to include that magnitude here. Okay, so hopefully this one also helped, and I will go forward to the next one. Feel free to stop, pause, rewind, ask questions as you need help.